Okay, so let's look at some examples here. We're told that from 0 to 4, the total area under f of x from 0 to 4 is 5. This total area is 5. And we're told from 0 to 2, it's -3. So that picture won't work. I need to have some negatives in there. I've got some -3 here. And the total area under the whole thing is 4, or is 5. So like we could just now figure out what this chunk needs to be. All of this combined needs to add up to 5. That means this positive chunk here has to be 8 to make this true. -3 plus 8 would be 5. So that tells me that the area just from 2 to 4 under f dx must be 8. Okay, now that was f. What about g? From 0 to 2 is 2. So this guy's up here somewhere. 2. Here's g. The entire thing, if I go all the way up to 4, this entire area should be -1, my net area. So I need to have a bunch of negative in there to cancel out that 2 and leave 1 left over below. That means this area must be -3 under here to make this statement true. So that tells me the integral from 2 to 4 of g of x must be -3 dx. So make sure you got all that. Now, what about this? The definite integral from 2 to 4 of f of x plus g of x. One of my properties of integrals says that the integral is a linear operator. I'm allowed to distribute. This would be integral or definite integral 2 to 4 of f of x dx plus the definite integral from 2 to 4 of g of x dx. I know both of those numbers now. That guy had to be 8. This guy had to be -3. The answer will be 5. What about this one? I have some definite integral. The definite integral is a linear operator. I'm allowed to distribute and pull constants out. So I'm going to distribute and pull this constant out. This object here will equal 3 times the integral from 0 to 2 of f of x dx minus 4 times the integral from 0 to 2 of g of x dx. And I know both of those numbers. I knew both of those areas. They gave them to me, right? That guy was -3. And this guy was 2. So I think that's 9 minus 8. I think we get 1. These are great problems about properties of integrals, definite integrals.